esophagus. Right? The way that we're going to do this is we're going to look at those various components of the tract. And the main thing, the only thing I can tell you is you must learn to identify the different types of epithelial tissue. If you didn't or don't remember those from AP1, well then you may need to go online or something trying to find that type of stuff, because honestly, this isn't the class we need to do that with, okay? But we got the stratified squamous epithelium here, okay? That's going to make up the mucosa of the esophagus. If you look from here to here, there's the submucosa. See a little adipose. Here at the very bottom, there's the beginning of the muscularis down there. Now, you don't have to identify those layers. I'm just telling you what they are, but nobody basically uses the submucosa and muscularis to try and identify these areas. What they will tell you to do is use the epithelial lining of the mucosa. And you got it right there, stratified squamous. Like I told you earlier in class, do not go through and try and simply memorize what this picture looks like. Stratified squamous epithelium can look slightly different depending upon the particular preparation that you have. So the concept is key here. I can't guarantee you that the slide that you may see or could see on your test will look exactly like this. Now, likelihood, I will guarantee you, it probably won't, because the slides get damaged, they get moved around, and the esophagus is an esophagus, and how do we know? You gotta have stratified squamous epithelium. So you need to really lock down with those tissues if you haven't previously done so. Next up, we're going to see what the stomach meets the esophagus. That is called the gastroesophageal junction. That gastroesophageal junction, if you look at one half of it, over here toward more of the left-hand side, / bottom of the screen there, it looks more like what we just saw, the esophagus. That's because it is the esophagus. But if you notice, it's kind of a hard division if you start to move superiorly there, and then you cross that division, and it doesn't look like stratified squamous epithelium anymore. That is the beginning of the stomach. Like I said, this is a gastroesophageal junction. Gastro for stomach, esophageal for esophagus is what the two mean. The stomach is marked, at least you can't really see it here, but it's got simple columnar epithelium. Those little depressions that you see in the surface of the stomach, those are called gastric pits. Also fairly denoted or distinctive, if you will, of the stomach. So, gastroesophageal junction, esophagus more inferior, stomach more superior.
Where are the pits, you said?
The indentations that are throughout. And just another more magnified view, you can see more of the esophagus here, more of the stomach there. So if we didn't think it changed, you can definitely see that the change in appearance from one area to the next. That moves us into the small intestine. I'm going to give you the image that usually is more distinctive. This one here, that's actually at the jejunum. Okay? What you see in those long, slender projections, if you go back and you compare and contrast the two, you'll see that the stomach has kind of these shorter indentations. Those are your gastric pits. They're not very deep at all. But within the small intestine here, these villi, the finger-like projections are long and slender. And it makes these very long, kind of narrow tunnels. They're not really called anything, they're just little depressions in between the villi, but those villi are distinctive of the small intestine. So, villi here, like through the jejunum. Do you have to call jejunum? No, you don't. Okay, I'm not looking for you to do that. So look when you tell me small intestine, okay? Now this isn't the only area of the small intestine that's in the set. So, if you look, other areas such as, here's the duodenum. In the duodenum, the way that we tell the difference is that the villi look different. The duodenum, the villi are usually shorter. They're a little bit wider at the base. If we went back and compared, which I'm probably not going to do, the base of the villus is here. You see it come up like that and then come back. But this is wider than what you saw in the previous slide, okay? It's also, if you stretch it out, these are kind of bent up, but if you stretch them out, they would be shorter than what were in the previous slide as well. The reason is because there's not a lot of absorption going on in the duodenum. There's mainly digestion. So you get longer villi where the most absorption occurs, which is actually through that second section, the jejunum. The ileum is easy, because you're going to see something that looks like villi, but in addition to those villi, you're going to see these little circular shaped structures here. Those are Peyer's patches. Remember, when lymphatic system. You have to identify those in the little lymphatic lake. Well, here they are underneath the scope. They look like maybe note from your lymphatic system, those germinal centers and lymph nodes. They're not germinal centers, but they are marked, okay? Collections of B and T cells that are lodged into the mucosa here of the ileum. Right? So,
And what are they called?
Peyer's patches.
You said B and T cells?
That's in the area.
Collection of B and T cells. Next up, at the small intestine, of course, would be the colon or large intestine. Usually easy to figure out because it's going to have multiple small circular shaped glands throughout its mucosal lining here. So you look throughout here, all these little circles, those are all absorptive glands. They're going to help its large intestine there absorb fluid as it moves through. It's the most distinctive characteristic I can tell you, okay? If you look right here, that looks like a Peyer's patch. That's just malt, honestly. It's a random, you don't see anywhere else. It's not there anywhere else, right? So it's just randomly spaced. Remember how I told you malt is sporadic? It doesn't happen except regularly in that Peyer's patch? Well, you saw the Peyer's patch, there were 1, 2 next to each other. Here, one random piece. So that tells you kind of that this isn't a small intestine because it's not regular. All right, accessory structures. Starting out at the top, we're going to look at the salivary gland. Salivary gland here up underneath about 10x mag. To me, the one thing that you need to look for is the secretory portion of the gland. It's usually nice and circular, like what you see here, 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 here. If we go up the magnification on that circular shaped area, you can really see the simple columnar epithelium that makes it up. What's happening is the saliva, the enzymes are being secreted into the lumen, and then they're draining through various ducts in order to ultimately get to the oral cavity. So look for these circular shaped secretory portions that are lined by simple columni. Nothing else is going to look like that. Nothing else is lined like that. All right? So you definitely need to make sure that you're on top of it.
And they're called what?
Salivary glands.
No, the little circular shapes.
The secretory portion. Next, we want to take a quick look at the pancreas. The pancreas is the pancreas is the pancreas, the same one that you saw in the endocrine system. There we concentrate on the islets, but here we need to focus on the acini. The acini are all those cells responsible for making the enzymes like amylase, pepsin, stuff like that. Okay, so this is where your digestive enzymes are coming from in the pancreas. Last but not least, the liver. Hexagonal in shape. The liver lobules there. If you look at any images in your book, I think there's actually a histological picture or image of the liver in your lab manuals. It'll look roughly like this. I walked you guys through the blood flow to the liver last week, right? Hepatic portal vein and all the artery stuff. I did that. See if I can do that. I didn't pull up a presentation or images from the book.
No.
Oh, that's what's around with y'all. Anyway, it's not a big deal. I was going to show you something, but I'm explain to you over that. What do I say? The liver lobule, yeah. You will see that in the center here, this area is called a central vein. I'm going to go up and down. And what's happening here is that blood from the hepatic portal vein, blood from the hepatic artery, once it hits your liver lobule, it's going to flow through these little cracks. These cracks are called sinusoids. Now, the blood from the hepatic portal vein is going through your liver in order to be detoxified, cleaned up. The blood from your hepatic artery is mainly meant to try and nourish and supply oxygen to those cells. So there's kind of like these two different supply chains, if you will. And each one is having a different function within the liver. They move the blood, that is, it moves toward the central vein, and that way it connects to your hepatic vein, and the hepatic vein then goes to the inferior vena cava. So there's a little flow pattern there through the liver. You don't have to identify any of the parts in here, but you do need to be able to tell me that it is the liver. And this is fairly consistent. You should look for that hexagonal shape, because that's kind of diagnostic with the central vein in the liver.
Not all of it's from the liver, but that's the liver.
not to identify different parts to it. I'm not just gonna do that. Alright? Alright.
You good?
I'm good.